Hello. I intended to give you some useful hints to go on with the first practical work assignment and to the second stage of that assignment. And as you hopefully have been able to derive, the Hamiltonian for the system can be written in this kind of form, where you have first of all this potential energy, which is dependent on the tilting angle, and then there are some terms which are dependent on the terms of momentum of inertia and also the momenta. There are, you can see p theta, p psi in two terms, and p phi in one of these terms. If you have been able to derive the equations of motion from this using Hamilton's equation of motion, that's very good. If you implement that into a MATLAB script, one of the practical questions is what kind of initial conditions you should use. I think there are some useful relations you can use. For example, the precession angular velocity can be written in terms of the tilting angle theta and the momenta p phi and p psi, as you can see. So if you start from precession velocity or precession angular velocity, you get a relation between these two momenta and the angle. Then there's also this angular velocity around the symmetry axis that can be related to these two momenta and the tilting angle. And then there's a simple relation between the angular tilting velocity and the corresponding generalized momentum. Well, I give you one hint, and I hope you can find it useful. What if the precession is zero in the beginning, when you start simulation, when time is zero? Why not start with omega, this capital omega equals to zero? Well, if you look at this condition, that means that p phi should be equal to p psi times cosine theta. All right. And okay, this term is zero. Then that means that also this Hamiltonian, this first term in Hamiltonian is zero. Then you should choose one initial tilting angle and choose the value of energy. So you know that Hamiltonian gives the total energy. And to simplify things, choose also p theta equals to zero. So that means that if angular velocity for precession is zero, that means that this first term in Hamiltonian is zero. If p theta equals to zero, that means that this term is also zero. Then that leaves us with these two terms in Hamiltonian. And so that means that Hamiltonian equals to p psi initially over squared over 2i3 plus mgr cosine theta. That's equal to energy. So if you choose energy, a value for energy and for tilting angle, then you can solve p psi in the beginning. And also because p psi is omega is zero, then that means that using this value you can derive, you can equate this p phi minus p psi cosine theta zero. So the initial value of p psi will also give you the initial value of p phi. So with these conditions, no precession, and given theta zero and energy, it's fairly simple to choose the initial conditions for simulation. Thanks.